Hi everyone, my name is Jean Park and I'm a Community Engagement Coordinator for API Forward Movement's Clean Air SGV campaign. Thank you all for taking the time to virtually attend our Clean Air Educational Workshop. And before we get started, I'm going to go ahead and share a link to a quick survey that we'd love for folks to fill out. During these workshops, we usually administer a pre-presentation and post-presentation survey so that we can collect feedback on our workshops and also gauge how much interest there is from folks who'd like to get more involved in the work that we're doing. So please feel free to copy the link on the slide, or you can scroll down to the description box below this video and find both links there as well. These should only take about a couple of minutes, so please feel free to pause the presentation to finish the survey as well. So with that being said, we're going to go ahead and begin our presentation first with a little bit of information about who we are as an organization. At our core, API Forward Movement is an organization focused on equal access to healthy food and a healthy environment. We aim to be inclusive of all communities, but we are specifically targeted when it comes to Asian and Pacific Islander communities, since we're one of the only API serving organizations focused on health and environmental justice in the nation. Our work is currently focused on 4 key aspects that aim to foster those vibrant and healthy communities. The first being culture and community health. We've been able to serve an estimated 7,500 families in 8 different languages every year. We believe that language accessibility plays an important role in communicating both public health services and culturally relevant information to the residents of San Gabriel Valley. We also work to provide healthy food access and education through programs such as HEAL and Food Routes that provide nutritional education and sustainable food systems. Another focus of ours is active living and transportation, where we can amplify programs like the Chinatown Fit Club. And lastly, our environmental justice work, which encapsulates programs such as the Clean Air SGV campaign, tobacco prevention, and Nature for All, which are all programs that advocate for less air pollution and healthier environments. And if you'd like any more information, our website at apifm.org also houses important information about the work that we do, so please feel free to check that out if you're interested. And in this presentation, we'll focus a bit more on the work being done by the Clean Air SGV campaign. We'll be discussing information about the program and why this matters, what's in the air we breathe, such as particulate matter, information about our purple air sensors, and what you can do to further this work as well. So before diving in, I want to share some history of the work that we've been able to accomplish as an organization. Before 2017, APIFM has had a history of advocating for clean air with its work on the EPA's Particulates Matter project, as well as providing educational workshops in parts of Asia. And since the start of the Clean Air SGV campaign, we've been able to install 50 purple air sensors in the SGV area between 2017 and 2018. And as we currently work to install more in Alhambra and Monterey Park, we hope to identify trouble areas with that data in order to advocate for better air quality on a local level as we move forward. And so why does all of this ultimately matter? Because we're able to link poor air quality with negative health outcomes. Poor air quality or the presence of air pollutants such as particulate matter is important to be aware of because it can lead to several health side effects. Particles start becoming inhalable at 10 micrometers or smaller, so that's when we start noticing various health impacts that different sized particles have on our bodies. So for example, particles at 10 micrometers or smaller are prone to affect our lungs, causing a variety of issues such as those mentioned on the left. Particles that are smaller than 2.5 micrometers can start damaging and contributing to skin and eye diseases. Particles that are smaller than 1 micrometer can contribute to the formation of tumors. And particles that are smaller than 1.1 micrometers have been linked to a greater risk of cardiovascular diseases. So when we breathe in these particles of different sizes, we have to keep in mind that it can affect us negatively in many different ways and also at different stages of life. While we know that air pollution can be harmful at all stages of life, often making folks prone to asthma attacks, heart disease, and others, it is particularly damaging for newborns as bad air quality can affect them long-term, and for seniors as well, as they're more likely to experience heart and lung problems. And as we dive deeper into air pollution during this presentation, I first like to begin the conversation with a very basic question. What is in the air that we breathe? And often when I pose this question in workshops, Participants will often come up with a few of the answers on this slide, and as you can see, the answer encapsulates a variety of components. So mostly nitrogen and oxygen, but also contains water vapor, carbon dioxide, argon and other gases, and ozone or O3, which contributes to the photochemical smog that we experience here in Los Angeles. And before we answer that question further, we have a photo of the 10 Freeway. And for those familiar with the area, know that Mark Keppel High School is just to the right of this stretch of the freeway, as well as other residential neighborhoods. And when you look at this picture and think about all the students and residents who've been living and working near this amount of traffic and air pollution, it begins to complicate that original question that was posed just a minute ago. So circling back, just based on the image that we saw, folks will often have a different answer to this question, one of them being air pollution, which is defined as any substance in the air that can cause harm to animals or humans. And as we pay attention to particulate matter, we find that air pollutants can come in the form of many gases, as well as solid and liquid particles. So for example, we have gases such as ozone, which are byproducts of photochemical reactions between other air pollutants, contributing to that formation of smog. Carbon monoxide exposure has also been linked to a myriad of health side effects, can also contribute to brain damage as well. Nitrogen and sulfur dioxide can contribute to respiratory irritation and reduced lung function. Carbon dioxide, which is also the primary greenhouse gas emitted through human activities, can also play a role and negatively affect our lungs. VOCs, also known as volatile organic compounds, are human-made chemicals used in the manufacturing of paints, pharmaceuticals, and refrigerants, meaning folks can also be exposed to pollutants inside of their homes. And during the COVID-19 pandemic, we've seen the increased use of germ-fighting cleaners and disinfectants, many of which evaporate and release VOCs as well, also contributing to in-home pollutants. And being exposed to particle pollution can also negatively affect our health. Particle size is often directly linked to their potential for causing health problems, which is why you'll see acronyms like PM2.5 or PM10. And we are also often exposed to moderate to high levels of lead and black carbon in our environments as well. So with all that being said, we've touched a little bit on the common air pollutants that people are often exposed to. We can now focus a little bit more on one air pollutant in particular, known as particulate matter, or PM for short. PM is actually a complex mixture of extremely small solid and liquid components. Particles can vary in size, shape, chemical composition, and are often defined by their diameter, as you can see in the image to the right. Anything with a diameter of 10 micrometers or less are inhalable into the lungs, so things such as dust, pollen, and mold can start causing negative health effects. And in this presentation, we'll be focusing specifically on PM2.5. So that's particles that have a diameter of 2.5 micrometers or smaller, which is about 20 to 25 times smaller than a strand of hair. There's also particulate matter that is classified as ultrafine, which means anything less than 100 nanometers in diameter. And this is particularly harmful because these can actually penetrate our skin. So even without breathing in these particles, our bodies can still be negatively affected with exposure to these ultrafine particles. The presence of particles in the air also vary depending on three different processes. The first being sedimentation, when gravity causes particles to settle. Condensation, when water collects as droplets. And lastly, coagulation, when individual small particles can collide and form into larger particles. And so now that we know a little bit more about the characteristics of these particles, we can start identifying where these particles are being emitted from or how they're being formed in the air. So the first being combustion, which is literally just the process of burning. Another source of origin is evaporation, when liquid turns into gas or vapor. And finally, we have weather, which just refers to the state of our atmosphere. And so now that we've touched a little bit on the formation and emergence of particles, we can talk more specifically about the sources of origin. And as you can see to the graphic on the right, 20% are coming from stationary and general area sources, 39% from on-road mobile sources, and 41% from off-road mobile sources. And before we get into each one of those, this page is an illustration of the South Coast Air Quality Management District, which is the air pollution agency that's responsible for regulating stationary sources of air pollution in the South Coast Air Basin. And so as you can see, the district covers parts of 4 different counties, including LA, Orange, San Bernardino, and Riverside County. And when you focus on Los Angeles specifically, you can see the big cluster of yellow and pink with other small clusters around that area, which is signifying the overlap between areas of poor air quality and communities that are mostly made up of non-white residents, which is important to keep in mind as we discuss how communities of color are disproportionately and continue to be disproportionately affected by air pollution. So going back, where do these particles come from? We can start by reviewing some of the familiar stationary sources, which include refineries, power plants, gas stations, road dust, paints, and much more. On-road mobile sources are pretty self-explanatory. They're anything that moves on the road, such as cars, buses, trucks, motorcycles, and scooters. And this picture also captures the 10 freeway, also full of cars and trucks. You can see a bus as well as a train on this one freeway, which all happen to be in close proximity to schools and neighborhoods. The train, however, is actually classified as an off-road mobile source, along with ships, planes, construction equipment. And we have a photo of LAX on this slide because San Gabriel Valley is actually in the landing path of flights heading into LAX, which means we have planes descending over these communities on a regular and daily basis, constantly contributing to the particle pollution in that environment. So some other factors that affect PM 2.5 trends include phenomena such as summertime SOA formations. SOA stands for secondary organic aerosol, which are caused by different gas and solid particle emissions, basically reacting to one another as well as with the sunlight to form these fine and slightly larger particles in the air. So again, contributing to that particle pollution we talked about earlier. Wildfires are also huge contributors and emitters of fine particles such as PM 2.5. And lastly, we have wintertime temperature inversions. These inversions, which are often caused by layers of warm air over cold air, trap pollutants, which result in a stabilizing atmospheric condition. And so when you think about the region of San Gabriel Valley, the location of these communities, they're in between these foothills that trap pollution like a bubble. So unfortunately, this means that the SGV area experiences more smoggy days, in addition to being surrounded by the 710 and 605 that support those on-road mobile sources mentioned previously. This map illustrates the major stationary sources within the South Coast Air Quality Management District. And as you can see closer to the coast, we have a cluster of these by the Port of Los Angeles and the Port of Long Beach. These are 2 of the largest ports in the country, from which 60% of the nation's containerized goods come from and are transported throughout the country. So while these stationary sources are settled by the coast, the rest of the Southern California region still feels the subsequent effects of air pollution through what is known as the goods movement. This 2012 map shows the major truck flows going in, out, and throughout California. The concentration of the system, while understanding that cities and residents often rely on an efficient and growing goods movement system, we also have to acknowledge that it's been causing lots of negative impacts to our health. So when we look at Southern California, we can clearly see how this map illustrates the impact of that goods movement. We're surrounded by the system of transportation that is continuing to affect the air that we breathe. This next photo shows a map of a US-wide truck flow from a 2018 Caltrans report. And as you can see, there's still a big concentration near the LA area because this goods movement system is continuing to expand as we move forward. We've seen the growth and popularity in services like Amazon, which are big contributors to this issue, not only because this puts more vehicles on the road, but also cultivates expectations and desires for consumers to receive their goods almost immediately. And in this next graphic, this chart illustrates what the goods movement looks like for individual products. So let's take our cell phone, for example. This graphic does a great job at illustrating that flow, starting from the factories that produce these goods, then to the ships that carry, to the ports that transfer, and then to trucks, trains, rail yards that transport the goods, and eventually distribution centers that work to deliver those goods. It's important to remember this process because understanding this can motivate us to seek alternative ways to get our goods as well. So in this next section of our presentation, we'll be discussing localized air quality data and its importance. But first, this is another question we like to share with those participating in the workshop. How far away from a major roadway should you be? So for reference, 100 meters is roughly the size of a football field, including the end zones. And in these workshops, we often get 300 or 400 meters as guesses, but the correct answer is actually 100 meters. And we like to juxtapose this question with another photo of the 10 freeway, which is right next to a residential street. And folks can clearly see that the distance is nowhere near 100 meters, meaning that the proximity to traffic pollution is a major source of air pollution to residents living near busy roads or freeways. One of the ways we've been able to call attention to the increased air pollution residents face is by measuring localized air quality data. Purple air sensors are low-cost air quality sensors that connect to a larger network that can provide real-time measurement of air quality on a public map. This next image is just a guide to help folks identify various components of these sensors, including number 1, which is the sensor body itself. Numbers 2, 3, and 4 represent the micro USB, power supply, and extension cord. And number 5 shows the optional screws and zip ties that come with the sensors for folks to mount. So how do these sensors work? This image shows what's happening inside the sensor. And as you can see, there are 2 lasers inside. The purpose of having 2 lasers is to ensure accountability in case one doesn't seem to be working, or one is showing an exaggerated reading, we're able to count on the other for a more accurate reading. In each of these sensors, there's a small fan which sucks air into the device, and then the lasers within the sensor are able to count the particles that are entering. And as you can see on the slide, these counters are able to measure particles anywhere between 0.3 and 10 micrometers. And these sensors are also able to measure temperature and relative humidity as well. So once installed, each sensor can be registered into the Purple Air map. These sensors can also be rented as well, but even if you don't have one of these sensors, you can still visit their website, purpleair.com, which is an open source website that shows a map of all of these sensor readings. So clicking on one dot, which represents one sensor, will allow users to see real-time information on that local area's Purple Air sensor readings, as well as a 7-day reading, which gives users an idea of the air quality trends in that local area. In the map data layer menu, there's an option to select raw PM2.5 in micrograms per cubic feet, which provides real-time data from Purple Air sensors as opposed to the default US EPA PM2.5 AQI setting, which shows the average readings based off of the air quality index. The great part of utilizing a resource like Purple Air is the ability to see precisely what local areas are facing in terms of pollution. Sometimes regional air quality data isn't able to pick up localized data in this way, so it's a great tool for people to become more familiarized with their neighborhood and identify ways to address air quality issues within the community. So these next few slides will be showing screen grabs of the Purple Air map focusing on California during wildfire seasons. As some of you may know, a couple years ago, California experienced one of the deadliest and longest wildfires. In November of 2018, the Camp Fire ignited around North California's Butte County, which lasted over 2 weeks. And in the same week in Southern California, the Woolsey Fire erupted in LA and Ventura County, also lasting for about 2 weeks. And as you can see on this map, the concentration of deadly and toxic readings in both Northern and Southern California were due to those wildfires. And as we've unfortunately witnessed in 2020, the months of August and September have also brought more wildfires. And as you can see on these screenshots, how that has affected the way that these sensors are counting this increase in particles and showing how various areas show up on the air quality index. Both of these screen grabs were taken on September 11, 2020, just a week after the Bobcat and El Dorado fires had ignited on the West Coast. The image on the right is interesting because you can compare the air quality on the West Coast compared to the rest of the continental US. And you can see how there's a major difference in the air quality that was being measured there versus anywhere else in the country. We have another screenshot of the SGV area about 2 weeks after the Bobcat and El Dorado fires ignited on September 15th, 2020. Even after containment efforts, there's still terrible air quality in the area because of the lingering particle pollution, which is also affected by other factors as well. And so despite the dangers that wildfire season can bring, there are ways to protect yourself from unhealthy air caused by these wildfires. We really encourage folks to stay indoors as much as possible to avoid exposure. But if you do plan on going outside, it's recommended that folks wear a mask, preferably an N95 respirator. Another simple thing is making sure that windows and doors remain closed. Also, a lot of people tend to forget about their air conditioning unit. If it's not set on recycle or recirculate mode, then a lot of times these systems will draw in air from the outside, which will have a negative impact on the air that you breathe indoors. We also encourage researching and using air filtration devices with a HEPA filter. HEPA stands for high efficiency particulate air and is able to trap 99% of particles that are 0.3 micrometers or larger. Also, avoiding smoking or using fireplaces, candles, incense, or vacuums can also help protect yourself from these particles. This slide shows another great chart that maps out the various health risks depending on air quality sensor readings. So the green and yellow rows indicate that readings of 69 micrograms per cubic meter represent low to medium health risk. It's letting folks know that it's okay to be outdoors. Yellow indicating to folks that air quality is acceptable, but there's still potential for small exposures to air pollutants. Readings of 70 micrograms per cubic meter or more as high or very high health risk, meaning that folks can experience detrimental impacts from pollutants that are in the air currently. In the bottom left corner, the state of California has recommended that the average exposure should be about 12 micrograms per cubic meter on an annual basis. And since the state of California hasn't set an average for 24-hour periods, we found that the US EPA has stated the recommended average for 24-hour periods should be no more than 30 micrograms per cubic meter per day. So when we think about some of the wildfire days during 2020, we're unfortunately seeing triple the average 24-hour day recommendation. So as we mentioned before, Marquette High School is located just next to the 10 freeway. We were able to partner with the school to mount 4 purple air sensors around the campus to pick up reading levels throughout the day. And this photo on the left shows the various placements of each sensor, with number 1 being closest to the freeway. And on the right, we have a graph of the readings showing a spike in all 4 sensors during rush hour and an even greater reading in that first sensor that's closest to the freeway. And this makes sense with all the information that we know about air pollution with greater proximity to major freeways and traffic pollution. This next chart shows data from sensors over a period of time from March 2018 to February of 2019. And what's interesting here is that you can see the huge spike in July, which is correlating to the 4th of July celebrations, meaning there were more outdoor barbecues and firework displays. This next graph is an illustration of the 2019 4th of July celebrations in comparison to 2020. It's a little hard to read, but the red and blue lines indicate the 2019 Alhambra and Monterey Park PM 2.5 levels, and the gray and orange lines indicate the 2020 Alhambra and Monterey Park PM 2.5 readings. We believe that the 2020 readings, which were about 3 to 4 times higher than in 2019, is due to the stay-at-home orders. Because people weren't able to gather in large crowds to view one large firework display, a lot of folks were experimenting with fireworks individually, which may have contributed to the significantly higher readings for 2020. This next image shows a 12-month daily AQI chart of Marquette High School. And as we can see, starting in June, we begin to see higher readings in the summertime. And in October, November, December, we start seeing that the area is experiencing some very high readings, which are caused by the wintertime temperature inversions that we had mentioned earlier in this presentation. And so with all that being said, there are things that you can do to push back on negative air quality. These include simple things such as seeking alternative environmental cleaning methods, such as using vinegar, baking soda, and other non-toxic cleaners. Learning about groups such as the Environmental Working Group, which aims to empower people to live healthier lives by sharing information and practical solutions to protect yourself and others. They offer consumer guides that grade cleaning, health, and beauty products based on how environmentally friendly and safe they are to use. And they make it really easy for everyday consumers to navigate products. So definitely make sure to check out their site for more information. Another step we can take is purchasing locally grown produce to lower transportation needs. This is again going back to understanding the goods movement and how we can lower our carbon footprint by shopping at local farmers markets and other local small businesses. And also seeking alternative transportation, such as walking, biking, and even carpooling with others if it's safe, and a bunch of other ways that we can reduce the negative impacts of air pollution. One of the great things about API Forward Movement is that we have also tried to set up practical ways that folks can start moving forward in the conversation of air quality and environmental justice in general. As we talked about earlier, these purple air sensors are a great way for residents to get a better understanding of their localized data and also contribute to the growing data which can be used to advocate for greater air quality measures at the local level. If you're a resident of Monterey Park or Alhambra, you're eligible to receive a free purple air sensor to monitor data in your area and also contribute to that growing network. These sensors will be distributed on a first come, first served basis and will only be available as supplies last. We're also appreciative that folks attend these educational workshops or decide to host one on their own for other groups or family members. We also encourage community members and residents to join APIFM's Stakeholder Working Group. The Stakeholder Working Group is the next step in making an impact on air quality in your community. We meet with local elected officials and policy experts to figure out what kind of policy solutions we would like to have in our local government. It's important for community members to be informed about air quality issues specific to SGV communities, and we hope to engage local communities in conversation in order to develop these tangible policy solutions that can improve air quality for all residents. And with that, that concludes the Clean Air Educational Workshop. As mentioned before, we appreciate folks taking a few minutes to fill out the post-presentation survey. It'll be incredibly helpful to see how effective these workshops are for participants, and folks are also able to express interest in hosting a purple air sensor at their residence or getting more involved in the work that we do in this program. If folks would like to follow up with any questions, please feel free to email us at cleanarsgv@apifm.org. We'd love to provide more information and share any resources. Thank you all again for virtually attending our workshop. To stay connected with API Forward Movement, please feel free to follow us on all of our social media platforms. And again, please feel free to visit our website for more information.